Hi to everyone. So here we are on the lesson of Monday. So today we'll be starting with the new lesson, which is chapter 5, lesson 4, which is solving special systems. Now, in the previous 3 lessons, we have learned the different ways to solve systems. We have learned about the elimination method, we have learned about the graphing method, and we have learned about the substitution method. Okay, so in this lesson you are going to be solving some kinds of special systems. Don't worry, it's very good. It's going to be very easy, even than the other 3 lessons which we did. Okay, so in this lesson, which is about solving special systems, now when you talk about systems, when in lesson 1, 2 and 3 we just had 2 equations which we told as systems, and then we were solving them, right? But there are some special systems which can have like more than one solution. In all those previous ones, we just got x is equal to 4, y is equal to this, right? We only got one coordinate as the answer. But there are some systems which are so special that either they have no answer or they have more than one answer. So when you are solving such special systems, what do you need to do? Okay, but before that, there are some words you need to just learn, or like you need to be familiar with. So let me teach you about these 2 new terms for you: consistent system and inconsistent system. Now, system means they are talking about those systems which we have done in lesson 1, 2 and 3, which means 2 equations. They are called the system. Okay, now see here, when 2 lines intersect at a point, okay, now that's what we have done. When 2 lines, when they intersect, when 2 lines join at a point, there is exactly one solution to the system, right? Just think you are drawing the graph of 2 lines. Okay, you have 2 different equations and you're drawing the graph and they meet in one place, right? That place we take as only one solution. Now, a system with at least one solution is a consistent system. So a consistent system means at least there is one solution. Now, when 2 lines in a system do not intersect, you know the lines which are not intersecting are called as parallel lines. When they are parallel lines, there are no ordered pairs that could satisfy both the equations. So there is no solution. Just think, like you're drawing 2 parallel lines, okay? Where do you think they will meet? The basic definition of parallel lines is that they don't meet each other, they don't cross each other, right? So when the equation or the system is given to have 2 parallel lines, that means that system will not have any solution. So a system that has no solution is an inconsistent system. So the system which has at least one solution is called as a consistent system, and the one which does not have any solution, that's called as an inconsistent system. Okay, now before I explain you the example, I just want you to watch the video related to this. It's not the same example, but yes, you can get more from that. So watch this video and then I will explain you the remaining part of the lesson.
Hey, let's take a look at some special systems of linear equations and see what things can happen. We've seen a lot of examples where we actually get a solution. Sometimes really weird things can happen. Like we can actually have no solution, or we could have infinitely many solutions. They both sound weird, but we can both see them, and let's try to detect when in fact we'll see each of those very bizarre and possibly unpleasant situations. Let's start with an example. So here's my linear system, my system of linear equations. Y equals 2x minus 3, and together with 2x minus y equals 0. Okay, I want us to look at this in a few different ways to really get a sense of what's going on here. So first of all, let's just take each of these equations and remember that they really came from lines. So let's write them in the traditional way that we write lines. Y equals mx plus b. The m is the slope, the b is the y-intercept. If I just take each and re-express it, well, the first one's already in that nice form. So slope-intercept form. This one's going to actually require a little tweaking. I'm going to have to add y to both sides. So then I have a y equals 2x. So I'll just write down y equals 2x. And for me, that's enough. let's actually think about it and see that, in fact, this system will have no solution. Now, why? Why was I able to tell that? Well, because look, I see that the slope of each of these lines, in fact, are going to be equal. So these two lines are parallel. They're parallel, and since one has a y-intercept of -3 and one has a y-intercept of 0, these are going to be two lines that never actually cross each other. They never intersect. So how can I find a point that's in common, right? When I'm looking for a solution to this, I want to find out where they actually touch. But these lines are parallel, and they have different intercepts, so there's no way they're going to touch. This, in fact, has no solution. I can stop right here because I see that I have different y-intercepts and the same slope. That's one way of seeing it, but let me actually show you a completely different way. A different way is to pretend we didn't notice that. If we didn't notice that, let's try to actually solve by, say, substitution. Well, y equals y, and so I'm going to see that if I plug this value in for that y, I see 2x equals 2x minus 3. If I bring the 2x over, so I'll subtract 2x from both sides. On the left-hand side, they drop out. I'm left with just 0 equals -3. 0 equals -3. Well, that is never true. That is never true, which means that these two together are never true, which means there are no solutions. So there's a second way that we can see there's no solution. Let me actually show you a third way, which is what we talked about at the beginning, which is to actually just graph these things. If we graph these two lines, what do we see? Well, one has a y-intercept of -3, which is right here. And the slope is 2 over 1, so up 2 over 1, up 2 over 1. And so there's one of the lines. Okay? And now where's the other line? Well, that actually goes through the origin because the y-intercept is 0. And I go up 2 over 1, up 2 over 1, and so forth. And you can see pretty clearly that these lines are parallel. They never intersect. Therefore, no solution to this system. Okay? So if we have the same slope and different y-intercepts, we know there are no solutions.
Okay, so that by that video, I think you would have got a very clear picture of what the lesson is about. They will give you a system, okay, and then you have to say the system has no solution or it has many solutions. So how do we do this? Now just remember that any system which has at least one solution is called a consistent system, and the one which does not have any solution is called as an inconsistent system. Now you can use three ways to find out whether the system has an equation or it has whether it has a solution or it does not have a solution. So starting with example 1, what are the three ways we can use? First one is we compare the slopes and the y-intercept. So the first way of finding out is by writing the equations in slope intercept form, which is equal to y is equal to mx plus b. So whichever equation is given, you write them in y is equal to mx plus b form, and then you compare them. If both the slopes are the same but the y-intercepts are different, then there is no solution. Again, I'm repeating. Arrange the system equations to be y is equal to mx plus b, and then check the slopes. Are the slopes the same? If the slopes are the same, check if the intercepts are same. If they are not the same, then the system has no solution. Okay, what I'm telling you, let me show you what I mean. This is what I was telling you. So the equation here is y is equal to x plus 1. Right? And the equation here is minus x plus y equals 2. So here it's already in the form y is equal to mx plus b. Here there is no m, means the slope is going to be, what is the slope going to be? Okay, you all, hopefully all of you remember, when there is nothing there, that means it is always a 1 there. So All what you need to remember is when there is nothing here, that means the slope is going to be 1. Okay, now that's not clear. I just wrote in case, like, if you want to know. Now, what I'm going to do is this part, this second one, I'm going to change it into y, the slope intercept form. So that's going to be y is equal to x plus 2, because 2 is already here, and minus x will come to this x side, it will become plus x, so x plus 2. Now, what are the two systems we have? We have the first system is y is equal to 1x, means x plus 2, right? I don't even need to write 1 there. X minus 1 is the first one, and the other one which I have is y is equal to x plus 2. Now just look at these slopes here. Are they the same? Just check if the slope is the same. Is the slope the same for this equation and this equation? Yes, it's the same. If the slope is the same, go on and check for the y-intercept. Is the y-intercept same for both the equations? Of course it's not. So when the y-intercepts are different for both the equations, that means that is going to have no solution. The system has no solution. So this was the first way of solving it, finding out, and that's the easiest way of finding it out. Now the second way is graphing the system. Okay, now how do you graph the system? Of course you know that you have to have your equations in the form y is equal to mx plus b. So let's see the first one. So this is going to have a slope of 1. That means 1 over 1. Remember, rise over run. So rise is going to be 1 and run is going to be 1. The slope intercept is -1. So this is the slope intercept of -1 here, where I'm pointing the cursor. And then from here, you will move up 1, right 1, up 1, right 1, up 1, right 1. So you will have the line. And it's like a mixture of all those things which we learned before. Then y is equal to x plus 2, which means the slope is going to be again 1 over 1, rise over run. But the slope intercept is plus 2, so 2, it's here. So you will have 1 up, 1 to the right, 1 up, 1 to the right. So you will join the line. When you join the lines, you can see that both of them are parallel. So of course, if the lines are parallel, means the system has no solution. Why? Because they don't cross each other at all, where we can get a common coordinate, right? So because they both are parallel, they do not have a solution. Okay, the third method is using substitution method. You can use substitution, you can use elimination, any way you want to. So this is the equation. What they are doing is, in place of this is the equation, in place of y they substituted x minus y. So minus x plus x minus y, x minus 1 equals 2, which means minus x plus x will give you 0. So minus 1 is equal to 2. Of course not. Minus 1 is never equal to 2. So again, that system has no solution. So up to you. You can choose any one of these three terms. What I feel is either method 2 or method 1 is easier, and method 1 is way too easy for us to find out, unless they specify. If they specify graph the system and then find, say the system has no solution, then yes, you have to do it. Okay, so let's try out this one. Okay, show that y is equal to -2x plus 5 and 2x plus 5, y equals 1 has no solution. Okay, now how are you going to show that this system has no solution? You can choose any one method from the three which we learned. I will of course choose the slope intercept form. Now this is already in slope intercept form, y is equal to mx plus b. I only need to change this one. So let me change it. That's going to be y is equal to -2x plus 1. Okay. Now what are the two equations I have? I have y is equal to -2x plus 5, and the it's equal. Fine. The next system I have is y is equal to -2x. I think that's enough because you can see the slopes are the same, plus 1. Now, how do you say that it has no solution? The slopes are the same, right? But the intercepts are not the same. The slopes are same, but the intercepts are not same. So that means the system has no solution. That's how you have to write. See how they have written? Just show how you did it and then say the system has no solution. You have to write this. The lines are parallel because they have the same slope but and different y-intercepts. So just write there the lines are parallel. So the system has no solution. Now you should be like informative enough to prove that why are they parallel, how are they parallel, how are they parallel? Because the slopes are the same, but the intercepts are not the same. So keeping this in mind, let me show you the other example. Now I just want you to watch this video too, so you can get to know what the next lesson.
All right, let's take another example. Let's see the bizarre things that can happen with systems of linear equations. Here I've got one. Y equals negative x plus 5 together with 2x plus 2y equals 10. All right, how can I deal with this? Well, first of all, let's just write it as a y equals mx plus b. First one, we're in good shape. So I'm trying to write the slope there. You can see it, -1. The second one, well, I don't know. This is sort of ridiculous. Look, there's a factor of 2, factor of 2, factor of 2. I'm going to divide both sides by 2. If I divide both sides by 2, what I see is x plus y equals 5. If I now solve for the y, that means I subtract x from both sides. I see y equals -1x plus 5. Now this sort of seems like a mathematical deja vu, because look, it's exactly the same as this. But really this one came from the second equation, and this one came from the first equation. What does this mean? It means that, in fact, these two equations are describing the same line. It's the same line, but in algebraic camouflage, so you can't tell. But really, they're the exact same line. So I'm asking for when are both of these satisfied? Well, they represent the same line, so what does that mean? It means they're satisfied all the time. So any x that you think of and any y that makes the first thing satisfied will automatically make the second thing satisfied. So in fact, this has infinitely many solutions. Infinitely many solutions. Now we can see that algebraically. Again, suppose we didn't notice this cosmic coincidence. We can solve this algebraically just using the substitution method. Well, y equals y. So if I set these two equal, I see -x plus 5 equals -x plus 5. If I add x to both sides, to bring that x over to this side, oops, sorry. Then I'm left with 5 equals 5. But there's no variable there. That's just a statement, 5 equals 5. And notice that's a true statement. And it's true no matter what x is. Every single x you can possibly think of will produce 5 equals 5. So that means that every single x will lead to a solution. All you've got to do is find the appropriate y, because in fact these two equations are actually the same. So we have infinitely many solutions. So now you've seen an example where you have a system of linear equations where you have no solutions, the lines are parallel, or a situation where we have infinitely many solutions because the two lines are actually identical, they coincide. So you got to watch it. There might not always be one solution to a system of two linear equations.
Okay, girls. So keeping that in mind, let me explain you about example 2, where the same video they're explaining about infinitely many solutions. Okay, so they have given you two equations here. Y is equal to 2x plus 1 and 2x minus y plus 1 equals 0 has infinitely many solutions. So we have to prove. Again, you can either use the slope and the y-intercepts, or you can solve it by using algebraic system. Fine. So first, let me show you how to do it by using the slope-intercept form. Okay. Now here, this is already in slope-intercept form. Y is equal to 2mx plus b, right? But here, something is different in this equation if you look at it. That's because that there is a number on this side as well as there is a number on the other side too. So all what you've got to do is first simplify this equation. Okay, so let's simplify this equation to be, this is going to be 2x, right, minus y equals 1. How 1? Because the minus plus 1 will go to the other side, so that will give you minus 1, right? Um, so all what you are left with here is, again, you have to change that to y is equal to mx plus b. So y is going to be 2x plus 1. Now, how did I get 2x plus 1? See, if you change the place, that's going to be a minus y equals 1 minus 2x, right? But we can, you know that we cannot have a negative sign with a variable. So what do you do for that? You have to multiply the whole equation with a negative sign. So when you multiply that, what happens is, of course, automatically the negative 2x will become positive 2x, right? So what are you left with then? You will be left with y is equal to 2x plus 1. In fact, here it should be minus 1 because it is 0 minus 1 is minus 1. So minus 1 will become plus 1 when you like multiply the whole thing. So that's how it became y is equal to 2x plus 1. I don't think I need to go into details for all these. Already we have taken enough algebraic things on these. So again, to make it clear for you, you just have to make this equal to y is equal to mx plus b. So here we have 1 on this side, so I bring it to the other side. That becomes 0 minus 1 is minus 1. So you are left with 2x minus y equals minus 1. Now to make it y is equal to mx plus b, minus y equals minus 1. You bring the positive 2x to the other side. That became a negative 2x. Now as you can see, there's a negative sign with the y. So you have to remove it, which means the whole equation you will multiply with a negative sign. So negative into negative, the y will become positive. Then negative into negative, the 1 will also become positive. Negative into negative, the 2x will also become positive. So y is equal to 2x plus 1. So now what are you left with here? That's what the deja vu he was talking about in the video. Both the equations are going to be the same because y is equal to 2x plus 1 is the first one, and even in the next one y is equal to 2x plus 1. There's the mathematical deja vu he was talking about because both the slopes are same and both both the intercepts are same. So which means if both the intercepts are same and both the okay, I'm stuck. Oh, both the slopes are same. That's going to be the system will have infinitely many solutions. So this is how you know whether it has no solution or infinitely many solutions. Now this was using the intercept form. Now the second way is solve the system algebraically, use the elimination method. You know how to do using the elimination method. We have solved systems by elimination method. So what they have done here is they have eliminated the 2x plus 5 from the systems. So when you solve it with the elimination method, I'm not going detail into that because already we have taken 3 days for that. So you will have 0 equals 0, which means the statement is true. With 0 equals 0, that means the system will have infinitely many solutions. So let's quickly try this part. Show that y is equal to x minus 3 and x minus y minus 3 equals 0. So here again, it's the same kind of equation. So let's put it right. So that's going to be x minus y equals 0 plus 3 is going to give you 3. Right? Minus 3 goes to that side, it becomes plus 3. So these are the two equations we have. Now this is already in the y-intercept form, but this is not. So let's change this to y-intercept form. So that's going to be minus y equals 3 minus x, right? Plus x will become minus x. Now when you arrange, you have to remove this minus sign, which means you'll multiply the whole equation with a minus sign. So as a result, what happens is y equals, the 3 becomes negative 3, and the plus x, negative x becomes plus x, because minus into minus will become plus. Minus here, it's already plus, so minus into plus will become minus. So let's arrange this equation properly. Y is equal to x minus 3. Okay, so this is the y-intercept form for this equation. So what are the two equations in the intercept form? We have y is equal to x minus 3 is equal to x minus 3, and the other system which we solved just now, that also has y is equal to x minus 3. So here is the magic, which means both the lines have the same y-intercept and both the lines have the same slope, which means both the system has infinitely many solutions. Only you have to differentiate between, if the slopes are same and the intercepts are different, it has no solution. If the slope is the same and intercept is also the same, that means it has infinitely many solutions. Okay, so this was your lesson for today. It was, as I told you, it's a very easy lesson. Okay, so here let me just show you consistent systems. You know what is consistent and inconsistent. Consistent means at least it has a solution. Inconsistent means there is no solution. So consistent systems can either be independent or dependent. An independent system has only one solution exactly. The graph of an independent system consists of two intersecting lines. A dependent system has infinitely many solutions. The graph of a dependent system consists of two coincident lines. All that you need to remember, independent system has one solution, dependent system has infinitely many solutions. Okay, now when you draw a graph for the independent system, it will only join in one place, two intersecting lines. It just has consisting of two intersecting lines. But this one, which is having a dependent system, it has consists of two coincident lines. Okay, now you can go through this part by yourself. You will understand what they are saying. So let's move on to the exercise page. That's page number 355. So I want you just to do only question 2 and 5 for now, and then the remaining 4 questions you will do as the homework. So question number 2, I will do I will do with you so that you can follow what I'm doing. Okay, so this is going to be, okay, so here, what is you have to show that each system has no solution. So let's show that this system has no solution. So this is going to be, already this is in y is equal to mx plus b form. So here there is nothing, means it's going to be 1. But here it's not in that form. So let's change this. So you can write it as y is equal to x plus 3, right? How x plus 3? Because minus x will go to that side, so it will become 3 minus x, right? But we don't usually write y is equal to mx plus b in this form, so we change it to like this, y is equal to x plus 3. Now, the solutions we have, the systems we have, one is y is equal to x plus 1, and the other system we have is y is equal to, there you go, again. The next system we have is y is equal to x plus 3, right? Now, how do you know that the system has no solution? Because the slopes are the same, but the intercepts are not, which means they are parallel lines. So how are you going to say? You will show this part and then you will say they are parallel lines, so they do not have solution. So the system has no solution. This is how you will do. I'm giving you 2 minutes. Try to do this by yourself and then we will discuss the answer. So your 2 minutes starts now. Okay, are you all done? It doesn't need much time because already one of the equations is in the form y is equal to mx plus b. So here there is no m, means it's going to be a negative 1. Okay, so here this equation you need to first simplify it. Simplify in the sense just write it properly because the number is on this both the sides. So let's write it properly. So that's going to be x plus y equals 3. How 3? The minus 3 will go to that side and it will become 0 plus 3. Okay, now all what you need to do is write the same equation in the form y is equal to mx plus b. So the x, when it moves to that side, it becomes minus x, and the 3 as it is on that side, so it becomes minus x plus 3. So what are the two equations you have now? The first equation is y is equal to minus x plus 3. And what's the other equation we have? That's also the same. Y is equal to x. The next one is also the same. Y is equal to minus x plus 3. So how do you know that it has infinitely many solutions? Because both the slope and both the intercepts are same, which means it's the same line coincidentally, right? Which means it has infinitely many solutions. I think this is the easiest way of doing it, just by finding the intercept y is equal to mx plus b. If you are ready to do the other two ways, any way which you feel is easy for you, please go ahead and do it. I felt this is more easier for every one of you to understand. So if you think no, you want to try the other way, you are most welcome to do the other way. There is no one going to stop you. You can try doing it the other way too. There's nothing harm. So this was all your lesson for today. So I just want you to do question number 3, 4, 6, and 7 as the homework. So in tomorrow's lesson, I'll be explaining you how to give the number of solutions for each system. So until I meet you in tomorrow's video, stay safe and take care of yourselves, and don't forget to do question number 3, 4, 6, and 7.